Hi everyone, in this time I talk about vector space, some most important question answer. Please you note down vector space. The first question number one. This question I provide shows that the vectors vectors 1 2 1 and 2 1 0 and 1 minus 1 2 okay from from a basis from a basis of the vectors space v3 over the over the field field over the field of real number NUMBERS numbers. First it is shows that the set shows that the set okay it is B. It is a number question. Shows that the vector this for the basis of the vector space v3 over the field of real number. And next shows that the set S is equal to 1 0 0 and 1 1 1 1 1 0 and 1 1 1 1 1 1 and 0 1 0. It is span span spans the vectors spans the vectors span the vector space R3. It is span the vector space R3. But is not a basis set basis set. So I provide this full answer, first question and second question. Answer first question. This shows that the vector this of basis of vector space v3 over the field of real number. So please you note down. We know that vf is equal to f. Vf is equal to f. Vf vector space, it is field of a finite dimensional vector space of a dimension n, that any set of n linearly independent, and it is linearly independent Li. Linear linearly independent linearly independent vectors 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 in V from a basis of V. Now this set, it is this set it is 1 0 0 and next 0 1 0 and 0 0 1. From FORMS a basis for V3 over the real number R over real number. Next, the dimensions of 3. Dimensions, it is 3 and in the dimensions 3, and we can show that this S is equal to 1 to 1. This 1 to 1 and 2 1 0 and minus 1 minus 1 and 3. 1 to 1 and 2 1 0 and 1 minus 1 and 2. Next is linearly independent. Is linearly linear linearly independent linearly independent. Then S is also from a basis of V3. S will also from a basis a basis of V3. Okay, next we have A1 1 to 1 plus A2 is equal to A2 to 2 1 0 and plus A3 it is A3 it is 1 1 minus 1 and 2 is equal to 0 0 0. Next you solve same process. Okay, A1 2A2 and A3. Next 2A1 A2 and minus A3. Same process A1 A2 A3. Okay, A1 A2 it is vanish and it is 2A3. Please you note down A1 plus 2 A2 plus A3. Next 2A1 plus A2 minus A3 and A1 plus 2 A3 is equal to 0 0 0. Okay, next A1 plus 2A2 plus A3 is equal to 0 and next 2A1 plus A2 minus A3 is equal to 0 and A1 plus 2A3 is equal to 0. Okay, the coefficient, the the coefficient matrix is 1 to 1, 2 1 minus 1 and 1 0 2. Note down please. It is 1 2 1 2 1 and minus 1 and 1 0 and it is 2. Okay, and it is A is equal to this matrix. Okay, next you solve this determinant value. So mod A is equal to 1. Okay, this and this 2 and next this it is minus 1. Okay, minus 4 and next it is minus 9. Okay, it is not equals to 0. Thus the rank the rank of A is 3. Thus the rank is A is 3. Okay, and you solve this equation, which is A is equal to A1 is equal to A2 is equal to A3 is equal to 0. Okay, it is determined value and it is this equation A1 A2 A3 value. So S is linearly independent. Okay, therefore the set S is linearly independent in the linearly independent. Okay, it's from a basis of for V3 field of real number. Okay, and next you know next it is it forms a basis. It's from a basis for V3 in the V3 in the V3 in the field V3 in the field of real number Okay, the first question which is complete. Next I talk about second question. Question number 2. Okay, question B. Okay, this question is shows that the set is 1 0 0 1 1 0 and 1 1 1 and 0 1 1. Okay, spans the vector space R3 but it not a basis set. Okay, you always remember is not a basis set. Solve this problem. We know that L is linearly span subset R3. Okay, and let A1 A2 and A3 okay, will be will be any, okay, sorry, it is DNA. A1, A2, A3, uh, B any elements, any elements, elements the vector of the vector space R3, of the vector space R3. Okay. Next, now A1, A2, and A3. A1, A2, A3 will belong to linearly span. Okay. If we can find, okay, A, B, C, D belongs to R3 such that, okay, it is A1, A2, and A3 is equal to A into 1 0 0 plus B into 1 1 0 and C into 1 1 1 plus D into 0 1 0. To solve this problem, it is A plus B plus C plus D. Okay. Put it this value A plus B plus C, A B C. Okay, sorry, it's 0, sorry, it is 0 means vanish, next comma, it is 0, it is B and C, and it is D. Okay, it is B plus C plus D, and next 0 0 C 0 means C. Okay, next we compare this equation, this, it is A1 is equal to this equation, A2 is equal to this equation, and A3 is equal to this equation. It A plus B plus C is equal to A1. Next, B plus C plus D is equal to A2, and C is equal to A3. Okay, we solve this problem. A is equal to, it is A1 minus A2 plus D. Okay, A is equal to A1 plus minus A2 plus D, and B is equal to, it is 7 A3. Okay, it is B is equal to equal D, which is A2 minus A3 minus D. Okay, and C is equal to A3. So A value and B value, and it is C value. Okay, in particular, if we take D is equal to 0, okay, D is equal to 0, we see that A1, A2, and A3. A1, A2, and A3 is equal to A1 minus A2. Okay, A1 minus A2, 1 0 0 plus B value, it is A2 minus A3. Okay, D value is 0. So A2 minus A3 into 1 1 and 0, and plus A3 into 1 1 1 plus into plus D value 0 and 0 1 0. Okay, we put it this value means it is A value means uh, A1 minus A2. Okay, B value means A2 minus A3, and C value means it is A3, and D it is 0. Next, this shows that, next this shows that next this shows that, okay, this shows that A1 A2 A1, A2, A3, okay, belongs to linearly span, okay, and hence and HNCE, and hence R3 subset linearly span, okay, and next linearly span is equal to R3, means we know that LS subset R3 and R3 subset LS, okay, and it is LS is equal to R3, okay, and next S, that is S span, SPAN, spans the vectors, spans the vector, okay, spans the vector space R3, okay, LS is equal to R3, and that is S spans the vector space R3. Again the relations of linearly dependent, again is the relation, again the relations of linearly dependent, okay, 1 1 0 0 plus minus 1 1 1 0 plus 0 into 1 1 1 plus 1 into 0 1 0, okay, okay, and next to understand shows that SHOW shows that S is not a basis, this is not a of basis of the vector of the vector basis of the vector space, basis of the vector space R3, okay, so that S is not a basis of the vector space R3, okay, so it is complete answer I provide. So next I talk about next question. Next question, please you note down. Question number 2. Okay. This question is find a basis. Find a basis. Find a basis of R3. Find a basis of R3 con PAINING containing the vectors between 1 1 0 and 1 1 1, okay. Find the basis R3 containing the vector 1 1 0 and 1 1 1, okay. The given two vectors are linearly, it is independent, okay. Please you note down this answer. These equations mean 1 1 0 and 1 1 1, okay. It is linearly LINEAR, linearly independent, independent, linearly independent, okay. For linear relations, and next linear relation, linear relations, okay. X 1 1 0 plus y into 1 1 1 is equal to 0 0 0 and gives x is equal to y is equal to 0, okay. And next let s is equal to 1 1 0, okay, 1 1 0 and 1 1 1 1 1 1, okay. Next consider the fundamental basis of R3, okay. Consider the fundamental basis of R3 is equal to 1 0 0 and 0 1 0 and 0 0 1. Okay, it is the fundamental basis of arithmetic. The fundamental fundamental basis in R3. Okay, A is equal to 1 0 0 0 1 0 and 0 0 1. Okay, next consider the generators. Okay, C is equal to, next note down, consider the generators. Consider the GENERA generator. Consider the generator. C is equal to 1 1 0 and 1 1 1 1 1 1, and next 1 0 0 and 0 1 0. Okay, 1 1 0 1 1 1 and 1 0 0 and 0 1 0 and 0 0 1 0 0 1, and this and this. Okay, it is 1 1 0 1 1 0 and 1 1 1. Okay, this is given equation and it is fundamental basis in R3. Next, which generate R3 a linearly dependent and its vector 5. Okay, next, which GENERATER generators R3, which generated R3 and is linearly linearly dependent dependent as it okay, as it contains five vectors. Okay, consider the linear relations. Next, consider the linear relation. Consider the linear relations A into 1 1 0 plus B into 1 1 1. Okay, 1 1 1. Okay, and plus C into 1 0 0 is equal to 0 0 0. Okay, next we solve. It is A. Okay, plus B plus C, B plus C, comma A plus B, C is not, A 0 B, okay, is equal to 0 0 0. Okay, next A plus B plus C is equal to 0, A plus B is equal to 0 and B is equal to 0, and find this ABC value. And here B is equal to 0 means A plus B is equal to 0 means A plus 0 is equal to 0, so A is equal to 0 and B is equal to 0. Okay, these two equations. And A plus B means 0 plus 0 plus C is equal to 0 and C is equal to 0. And therefore, A is equal to B is equal to C is equal to 0. Okay, and it is consequently, next, consequently, consequently the first three vector three vectors VCTOR is vector. Consequently, the first three vectors of C are linearly linearly independent. Independent. Okay, it is linearly independent. Okay, linearly independent, and therefore since R3 is dimension DIMENSION is dimension 3 means it is 1 2 and 3. three dimension. Okay, dimensions is 3. Next it follow it follows it follows that it it follows that okay it follows that 1 1 0 and 1 1 1 1 1 1 and 1 0 0. Okay, in is a basis is a is a basis of R3, is a basis of R3. Okay, so it is complete answer I provide. Okay, so next I talk about next question. Next question, question number 3. Okay, this question find the coordinate coordinate find the coordinate vectors a alpha is equal to 2 3 1. Okay, relations RELATI be relative to the basis b is equal to 1 1 1 and 1 1 0 1 1 0 and 0 1 0. Okay, 0 0 1 0. Okay, find the coordinate vectors of a is equal to 2 1 2 3 1 relative to the basis b is equal to 1 1 1 and 1 1 0 and 0 1 0. Okay, so let's start. And next also find also find the vector find the vectors in R3. Okay, whose coordinate vectors coordinate vector relation RELA relative to the basis to the basis b is equal to 1 1 1. Okay, 0 2 3 and next 0 2 minus 1 0 2 minus 1. Okay, this is minus 3 1 and 2. Okay, next let us to find the scalar a1 a2 and a3 such that 2 3 1 2 3 1. Okay, sorry, I repeat this topic. It is 2 3 1 is equal to a1 into 1 1 1 plus a2 into 1 1 0 plus a3 into 0 1 0. Okay, this equation it is 1 1 1 1 1 0 and 0 1 1 and 0 1 0. Next we find it is a1 plus a2 to 0 comma it is a1 comma uh, a1 plus a2 plus a3 comma a1 to 0 and it is 0. Next we compare this equation. It is a1 plus a2 is equal to 2 and a1 plus a2 plus a3 is equal to 3 and a1 is equal to 1. Okay, next to find a1 a2 a3. Next a1 plus a1 uh, next to understand a1 is equal to a2 is equal to a3 equal to 1. Okay, this is a1, a2, a3 value. Okay, hence the coordinates of r, hence the coordinate is coordinates of a are 1 1 1 1 1 1 1 1. Okay, 1 1 1. Let a be the required vector. Let a, sorry, alpha be the required, alpha be the required vectors. Then alpha is equal to 3 into 1 1 1 and minus 1 into 0 2 3 and plus 2 into 0 2 1 is equal to 5 3 5 minus 2. Okay, so this how to find alpha is equal to 3 into 1 1 1. Okay, minus 1 into 0 2 3 and plus 2 into 0 2 minus 1. Okay, let's find 3 minus 1 to 0 0 and 0 comma it is 3 minus 2 and plus 4. Okay, and comma it is 3 minus 3 and minus 2. Next is equal to is equal to is equal to 3, it is 4 3 is 7 minus 2 means 5. Okay, comma 3 3 cancel, it is minus 2. So thank you. I provide some most important question answer in vector space. Next I talk about linear transformations. Okay, so thank you, take care, goodbye. I probably missed some important topic. You not understand any mathematics, please you uh, tell me. I provide and full explaining this mathematics. Okay, and question answer. So thank you, take care, goodbye.